So 10.3 says prove giving reasons that AD is a tangent to the circle passing through AC and F. So here I just made a little makeshift circle and it passes through the points C, F, and A, and we are looking to prove that AD will be a tangent to the circle. As you can see in my diagram, it's definitely not a tangent, but for all intents and purposes, we'll pretend that it is, and we are simply trying to prove that this is a tangent. So drawing this little picture just helps us to visualize what it is we're actually trying to prove and makes it that much easier, even if it is by a little bit. So here we can say that the angle CAD is equals to 90 degrees. So CAD is this angle here, 90 degrees. And we are saying this because this is an angle in a semicircle. So if we look at the bigger triangle, remember what we're trying to do is use this bigger triangle's properties and prove that AD is a tangent to this circle. So to prove that if we were to draw a circle to these points, this would be a tangent. So we can only use properties of things that we do know, and that is the thing given about the bigger circle, and this will be one of them. So CAD is equal to 90 degrees, reason being angle in semicircle. So this angle in semicircle is just the angle subtended or created by CA, which is the diameter, which is equal to 90 degrees always. Then what we can do next is we know the value of A1 already because of our previous question. So A2 will be equal to 90 minus A1, and A1 is 90 minus X. This gives us a value of A2 of X. So since A2 is equals to X, we can also say A2 is equal to C. And this has been proven. Therefore, if A2 is equals to C, that means AD will be a tangent or is a tangent. And that reason would be the converse tan-chord theorem. Like that. Or you could start off immediately by saying CAD is equals to 90 degrees, and AC is a diameter. So here we're using similar reasons. Angle in a semicircle, that's the same reasoning over here. And AC is a diameter. Why do we say AC is a diameter? Because of the angle in a semicircle. So we know because it subtends 90 degrees, therefore it has to be a diameter. So it's the converse of angle in semicircle. So when you say converse, we're just saying that what we usually are trying to prove is what we're using to prove the other. So usually a diameter proves that this is 90 degrees, but in this case we're using 90 degrees to prove that this is a diameter. So that's the converse theorem for the semicircle. Now if this is true, then immediately from this we could deduce that AD is a tangent. And the reason here is the converse of the theorem that states a radius or a line from the center will perpendicularly bisect a tangent. And there are other reasons or other methods that you could use that are similar to this one, that you could find from this point that would allow you to prove the same thing, that A2 is equals to X, such as we already know that CE is subtending this angle here we could find a value for m1, which we've already done, and just use that m1 to prove that m2 is going to be, a2 is also going to be equal to x, but eventually you're going to be led to the same conclusion and deduce that AD is equals to a tangent.